This was the Precalculus Chapter 2 test taken on December 14th, 2018. This is versions W and X, and remember to cross that off. Your test is out of 24, not 28. Question number 1, use synthetic division to find the remainder of x cubed plus 2x squared minus 4x plus 3 for the factor of x minus 3. To use synthetic division, I have a binomial, so I'm going to set it equal to 0. Therefore, the 3 that I get here is a 3 as my divisor. The numbers I write for synthetic division are the coefficients. Coefficients are the numbers in front. 1, 2, -4, and 3. Remember, if you are missing a term, you're going to have to do a placeholder. So if you, for example, if I put my finger over -4x, that would be 1, 2, 0, and 3. So the placeholder would be 0x if I covered up that part. To use synthetic division, you're going to bring down the first term. You're going to multiply 3 times 1. You put that number here, and then you're going to add down. 2 plus 3 is 5. 3 times 5 is 15. -4 plus 15 is 11. 3 times 11 is 33, and you add those, you get 36. So it tells you to find the remainder. Essentially, this we use synthetic division. Now, it is multiple choice. I'm not checking your work. You can also use the remainder theorem. You can just put in 3 into the function. And then just evaluate it, and you'll get it to be 36 as well. Okay? Question number 2, multiple choice. Which polynomial graph below has at least 4 imaginary zeros? So this question is testing the idea of the fundamental theorem of algebra. And the idea that complex zeros come in pairs. Now I wanted to show you guys this for all of them. So that basically means that all the imaginaries, we have this equation for the fundamental theorem of algebra. The degree of the function tells you how many zeros there are. So for example, if you looked at this function, you should recognize it's a cubic function, which means it's going to have 3 zeros. Well, what combination of reals and imaginaries? Well, remember, the imaginaries have to come in pairs or evens. Well, if that's a 2, then that has to be a 1. Now, this one says at least 4. Well, we don't have 4 imaginary zeros, so it can't be A. Look at B. You should have picked up on that this is a 4th degree polynomial. You weren't allowed to use your graphing calculator, so you're just looking at its behavior. Another way of testing it, let me go over this one and then I'll show you guys D as well. This is a 4th degree polynomial, so that means it's going to have 4 zeros. Remember, imaginaries come in pairs, so this can either be... now, the reason why it's 2 and not 4 here, it could have been 4, right? But look where it crosses. How many times does it cross the x-axis? Twice, and those are shoot-throughs. So that means its multiplicity is 1, which basically means it has 1 real 0 here and 1 real 0 there. That's why it's a 2. This one has to be a 2, so this one does not match the 4 that we need. Here's another way of, maybe you're not sure of which type of, what degree does this have. Well, there's an equation that we talked about, the turning points. The turning point is the degree minus 1. Or n, the degree, they usually use an abbreviation as n. Okay? So for example, if I look at this one here, you're asking, I'm not sure which type of degree it is. Well, you can count the number of turning points. 1, 2, 3, 4. So this has 4 turning points. To figure out the degree for this one, I can just add 1 to both sides, and this is a 5th degree polynomial. Well, based on the graph now, I can count how many reals and how many imaginaries. Here is touching the x-axis is a bounce, so that's 2 reals. Shoot through, that's 3, 4, another shoot through, that's 5. So this one has 5 reals but 0 imaginaries. If you look at this one, you can count the number of turning points. 1, 2, 3. So you can do turning points. equal to n minus 1. 3 turning points is n minus 1. Add 1 to both sides, you have n equals 4. Now, can you see that this graph doesn't actually touch the x-axis? That's why your reals are zeros. Thank you. So your answer is C. Question number 3. It asks you to factor completely 2x to the third plus 3x squared minus 8x minus 12. I'm going to count the number of degrees, 1, 2, 3, 4. So I'm going to hope that we can factor this by grouping. If not, I can use the rational roots theorem. You can actually use both of these to solve the problem. Now, if you looked at this problem, I factored out the first two. I factored out an x squared. To double check, that's x squared times 2 is 2x cubed, and x squared times 3 gives me 3x squared. Now, when you're factoring by grouping, you're hoping that these common factors here in orange are the same. That's how you know you're going to factor by grouping. Over here, if I factor out as a greatest common factor a negative 4, I get 2x plus 3, which matches. Remember, you can double check by distributing. Negative 8 and negative 12. So I have this here. Now, if you wrote just this, that basically tells me you only factored once and I only gave you 2 points. Also, you got 2 points if you just found another factor, like one of these factors by the rational roots theorem. Now I have x squared minus 4. A lot of you guys left it like this. Here you have to factor again. How do you know if you need to factor again? Well, just try it. X squared minus 4 is really x squared plus 0x minus 4. A times c is negative 4. Your b value is 0. There's your placeholder. Two values that multiply to be negative 4 are positive 2 and negative 2, and those also have a sum of 0, or they add together to be 0. So my answer is 2x plus 3. This factors to be x plus 2, x minus 2. If you got this one here, I gave you 3 points, and then that just basically means you need to factor one more time. Some of you guys solved, so I'm writing out all of the how I scored it. So this one says factor and does not say solve. So if you wrote, like, I saw some students write x equals negative 2, positive 2, and negative 3 halves, and you boxed it along with that, that's too many responses. You're kind of showing me what your answer is. You're trying to show me all of your evidence that you know this information. You're not making me do the multiple choice. That would be, I wouldn't give you full credit for that. The extra credit question for your class was the main rival was Magnolia. That side was out of 2 points for your name, 2 points for multiple choice, 2 points for multiple choice, 6, 2, 4, 6. That side was, can I not count? Is that 10? Is that correct? Let's make sure that's correct. Right, 10. Just double check the back side when we finish it. Turn the page. Write, number 5, write a polynomial function of minimum degree in standard form with real coefficients whose zeros are negative 3 and I. So hopefully that was clear. That's not a 1. That's an I. Okay. I believe I just cut and paste that from last year's test, and I gave you guys last year's test. So you actually had all the solutions. If you think about that, this is a real, and this one's an imaginary. Remember, imaginaries, complex numbers come in pairs. So if you look again, you're like, well, Mr. Ng, I'm not sure which degree. Using the fundamental theorem of algebra, my degree is an unknown, but I have one real. And this is an imaginary, so it has to have a conjugate, so you're going to have 2 as your imaginary, so you're going to have a total of a third degree polynomial as your answer. Well, if you put those into your binomials, remember some kind of form of kind of like factored form is x minus p, x minus q, x minus r. You can use as many letters as you need. Remember, x equals negative 3 is the same thing as x plus 3. We talked about in class how this is kind of like your real for I is 0 plus I, so the conjugate here is you just change it to a minus. Now you don't need to write the 0, so that's a positive I, and this one is a negative I. And if you take the opposite of that, you get x minus I, and this one becomes x plus I. So if you got all of these factors here, I gave you guys, if you wrote all the binomials, 2 points, or if you just wrote these two, 2 points. A common mistake was to change this, negative 3 and I. Somehow students wrote negative 3 plus I and wrote that as one binomial. That was a mistake. And the second common mistake was to think that was a 1. Hopefully that was obvious, that was an I. Well, what do? You can just multiply these in any order. So that's the commutative property of multiplication. So if you multiplied, say for example, x plus 3 times x plus I, that's going to be a different work than mine. I just multiplied these two first. So they're in orange, x plus 3 times x minus I, that becomes x squared, negative xi, 3x, and negative 3i. Then with these 4 terms here, 4 terms times 2 terms is going to be a box of 8. So in blue here, this is what I have here at the bottom. Again, if you multiply the binomials in a different order, you'll have, our final answer will be the same. X times x squared is x cubed. X times 3x is 3x squared. X times negative xi is negative x squared I. X times negative 3i is negative 3xi. X squared I is x squared times I is x squared I. 3x times I is 3xi. I times negative xi is negative xi squared. And I times negative 3i is negative 3i squared. Now, the order that you write them is you write the x, then the i's, and then you're going to look for those that can cancel. Here's a positive and here's a negative, so I cancel those. This is a positive 3xi and a negative 3xi. Those cancel. If you recognize in doing these problems, you should have recognized that basically anything with the i's cancel. You learned last year, and we also reviewed in this class, I squared is equal to negative 1, so a negative times a negative is a positive, so that's x. I squared is negative 1, so negative times negative is positive. So my final answer for this problem is x cubed plus 3x squared plus x plus 3. Question number 6. Convert the polynomial into vertex form and graph in vertex form. So here I have g of x equals x squared minus 6x minus 16. To convert it into vertex form, you're just completing the square. I like to move this negative 16 over here. For those who decided to add 16 and put it to the other side of the equal sign, your mistake is you're trying to solve it by completing the square. You're not solving by completing the square here, you're just applying completing the square. Here I have now x squared minus 6x. I'm going to take my b value. My b value is negative 6. You have this formula. b over 2 squared. Negative 6 divided by negative 2 is negative 3. And negative 3 squared is 9. Put that in color here. Remember, just like your bank, they made a mistake on my bank. If they take out $9, it's fine if you subtract 9. They have to equal 0. So here, inside my parentheses, the reason why I wanted this 9 here is to complete the square so I can factor it. When you factor it, it is 1 times 9. Your b value is negative 6. Your two values are negative 3 and negative 3. Out here, that's going to read negative 9 minus 16, which is negative 25. You have two of these. This is called a perfect trinomial square. You have x minus 3 squared minus 25. Then you have the vertex form y equals a times x minus h squared plus k. That means the formula has this minus sign. So your h value is going to be a positive 3, and your k value is a negative 25. Your A value is 1, so it's going to open up. For my graph, it's going to be in quadrant 4, right 3 down, negative 25, and there is my parabola. You didn't need to know that negative 16. The original problem, when you graphed it, has a y-intercept of negative 16. You could put in... some of you guys try to just find your x and y intercepts. Notice how it doesn't have that in the directions, and you could have graphed it. But remember, it's asking you to convert it into vertex form, and vertex form is this one right here. Notice in this problem, I also didn't ask you to find... There's an ant. You see it? You see it? Yes, go towards the vertex. That's here. Right there. Where did you come from? Can you see it? That was a first. Number 7. For number 7, I just took the question from the previous years, and I think I just subtracted an x, or I just changed the number or something. Graph and make sure to label all your intercepts. F of x equals negative x squared times x minus 1 squared. There's a couple of ways that you can actually transform the problem to make it a little bit more user-friendly if you didn't recognize it. You could have done something like this: negative x minus 0 squared times x minus 1 squared. So in math, if you can, I tell them put on your math glasses. There's zeros and ones everywhere. You just have to know where they are. How did I solve this problem? Here, I just applied the zero product rule. Negative x squared equals 0. Divide both sides by negative 1. That equals 0. How do you get rid of the power of 2? Take the square root. X is equal to plus or minus 0. 0 can never be positive or negative, so x is just equal to 0. There's my x-intercept. If you notice, its degree or its multiplicity is 2. When you have a degree of 2, you're going to do a kiss. X minus 1, you solve it, equals x equals 1, and your degree is 2. Remember, when your degree is even, it's going to kiss. If it was odd, it would be a shoot-through. My basic graph is I'm just going to add the exponents. 2 plus 2 is 4. So x to the 4th is an even. The easiest even is an x squared, which means you'll start up and then end up. But then this problem has a leading coefficient. Everyone say leading coefficient. The leading coefficient changes it. Now it's going to start down, ends down. So those are my 2 blue arrows. When you approach 0, you're going to bounce off of it, but not go through it. And they call these rough sketches because we didn't learn something, but you can use something kind of like the intermediate theorem, which basically means like you can find values in between them and just substitute it in and find y value. Also, you know it's going to turn because here at 1, you're going to have a kiss, and then you're going to end here. So here we have a 4th degree polynomial graphed by multiplicity. So that side was 12 points, so 4 points for the free response. So your test is not out of 24, it is 22.